The next type of statistical graph we are going to discuss is a histogram. When a numerical variable is continuous, its possible values can vary by really small increments. As a consequence, there are no gaps between the class intervals. And our old way of doing things, using separated columns or stacks, like in bar graphs, will no longer work. In this case, we use a variation of a bar graph called a histogram. And the only difference is that the instead of separated bars, now the bars are all touching. So histograms you use when the numerical value is continuous. Number one, there are no gaps between the class intervals or columns. All of the columns are touching. The next thing you need to do is try as much as possible to have class intervals of equal length. And you use the endpoint convention. So if a value falls directly on a boundary line, what the endpoint convention is let's look at this. Group 1. This is, well, what we're dealing with is we're dealing with starting salaries of TSU from the graduates after they graduate college and they go get their first job, what their starting salary is. So in this group, group 1 is 45,000 plus to 50,000. Okay, group 2 is 50,000 over this. There's a little plus there to 55,000. And then group 3 is 55,000. So if you see here, there's 50,000 here and there's 50,000 here. So if someone earns 50,000, do we put them in group 1 or do we put them in group 2? Because 50,000 is listed twice. And that is why the endpoint convention is very, very important. This plus sign right here indicates that if it's over 50,000, then it goes in 52. But if it goes all the way up to 50,000, then it would be 50,000 would actually be listed in group 1. Anything over 50,000 would be listed in group 2, all the way up to 55,000. This plus right here means anything over 55,000 goes in group 3, all the way up to 60,000. And then lastly, anything over 60,000 all the way up to 65,000 would go in group 4. So that's what it means, these little plus signs. That's what the endpoint convention is. So here we have a frequency table using different class intervals. We want to make sure that each one of these class intervals is the same. So this is 5,000, this is a 5,000 difference, this is a 5,000 difference, and that's a 5,000 difference. If you see, here's the frequencies of each class interval listed. And so now we just need to take this information and graph it. So here I have my class intervals listed. These are the salaries. You know, my data ranges, my frequencies range from 0 up to 500. So I have my my y-axis labeled as such, number of graduating students, and I'm just going to graph it. So for my first class interval, it goes up to 250, which would be right about here. So I'm just going to make my first bar. Okay, and then the next one, 50,000 to 55, would be 500. So I'm going to go all the way up to 500. And notice that both of these stacks, these columns, they're touching. And that's the difference between a bar graph and a histogram. The next one would be 400, which would be right about here. And the last would be 200. And that's the histogram. The last thing would just to put the title, so starting salaries of TSU graduates, and make sure you include what n equals. N equals 1,350.